Which pair of reagents will react together in a redox reaction? So remember, the first one is an aldehyde. And aldehydes, they do get oxidized. You have primary alcohols, which turn into aldehydes, and which then further get oxidized to carboxylic acids. So you get RCOOH over here. So aldehydes, they do get oxidized with Felling's reagent, and you're going to get a red precipitate with Felling's. The next one, 3 is definitely not going to get oxidized because remember, ketones are resistant to oxidation. They don't undergo any oxidation. Uh, this one was for alcohols. TK again, I mean, this is the part where aldehydes, they do get oxidized, and ketones, they don't undergo any oxidation. TK, what about the middle one? The middle one is free radical substitution. That was the first reaction that you did. In the middle one, what happens is, I mean, the reaction is way more complicated. It has initiation, propagation, and termination steps. But the overall reaction, or if you want to just write a general reaction, one of the hydrogen gets substituted with Cl, and an HCl molecule is produced. So this is a very general reaction for free radical substitution or chlorination of alkanes. Now, is this a redox reaction? If you look carefully, you would notice that Cl over here has an oxidation state of 0. Cl over here has an oxidation state of -1. Its oxidation state is changing. Initially, it was a free element, and now it is changing into -1, which means there is reduction. There is reduction, and there would definitely be oxidation happening as well. So it is a redox reaction. So both 1 and 2 are correct. The third one is not going to be correct. Ketones are not going to get oxidized. Then the next one, is this clear? This question, first one. Ethan, is this clear? Maza, is this clear?
Yes, sir.
Okay, the second one. Question 39. An organic compound X reacts with calcium metal to produce a salt with the empirical formula Ca. So it is reacting with a metal to form a salt, so it's definitely a carboxylic acid. I mean, that's the only one that would produce a salt. Alcohols, remember, only react with very reactive sodium metals. So what could be the identity of X? So it's definitely a carboxylic acid. The first one is ethanoic acid. So ethanoic acid is CH3 and it's COOH. If it reacts with calcium, what's going to happen is that the H in the carboxylic acid is going to get substituted. It's going to form CH3, COO minus 1, and Ca is in group 2, so it's 2 plus. So if you do crisscross, the formula of the salt that's going to be produced is going to be, I mean, the negative ion is going to be doubled, plus H2 gas is going to be produced in the reaction. Now that indicates that so we need to figure out whether the formula of the salt is going to be this or not. If you look carefully, there would be 4 carbons over here. Uh, the number of hydrogens would be 6. So that is not going to be correct. The oxygens are 4, the carbons are 4, calcium is 1. Everything is fine except for the hydrogens. The hydrogens are in total over here, the hydrogen atoms are 6. So the first one is incorrect. And if the first one happens to be incorrect, then 2 and 3 are always correct. So option 2 and 3 are going to be correct in this case. Uh, so we're going to do option 2 and 3 just to be on the safe side, just to check. But remember, you don't have to waste your time. If the first one is definitely incorrect, then don't even think of actually attempting 2 and 3. 2 and 3 would always be correct. But we're going to try anyway. So butane dioic acid. What is butane dioic acid? It's bute, which is 4 carbon atoms. And dioic means there would be 2 carboxylic acid groups. So there would be carboxylic acid groups on both sides, and this would be hydrogens. So how would a salt be produced? Calcium is going to come in, and calcium is going to substitute the hydrogens. So calcium would form 2 plus. And which hydrogens are going to get knocked out? This one. So calcium is going to replace this hydrogen and it would form a -1 ion over here. And similarly, the other hydrogen over here would also get knocked out because that's also a carboxylic acid. So there's going to be a -1 charge over here as well. So it's basically two carboxylic acids. And the total charge on this ion is going to be -2 because there's a -1 charge over here and there's a -1 charge on the other side. So that means the charges are already balanced. So calcium 2 plus knocks out two of the hydrogens in the carboxylic acid groups, and the charges are balanced. So there's only going to be one calcium and one of this butane dioate ion. And if you look at the number of carbons, that's four carbons. There are four hydrogens over here. There are four oxygens, and there's one calcium. So which is why this option, butane dioic acid, is going to be the correct option. And always remember how a salt is going to be produced. A salt is always produced when the H in the acid gets knocked out, and in its place, a metal ion takes its place. Uh, so the same is happening over here, except that it's butane dioic acid. Carboxylic acid groups are on both sides. Okay, is this clear? Abba, is this clear?
Yes, sir. Yes, sir.
I said then, and methyl propane dioic acid is pretty much the same thing. What's propane dioic acid? That's three carbon atoms. Propane dioic means that there would be two carboxylic acid groups, and it's 2-methyl, which means that there's going to be a branch of methyl on the second one, which would be C, and H3. There would be one H with this. And the same thing would happen. Calcium would form a salt. The H over here is going to get knocked out on both sides. And this would form -1 ion. This would also form -1 ion, and calcium 2 plus is going to replace the H plus 1 ions. So the overall charge of this ion is going to be -2. So there's only one calcium needed, and you can total the number of carbon atoms and hydrogen atoms and oxygen atoms. It's exactly going to be this one over here. Now the next one is, which changes in bonding occur during the reaction of ethanol and hydrogen cyanide. Now this is a nucleophilic addition reaction. So what's a nucleophilic addition reaction? If I can open the board, this is halogenoalkanes. I think it's below alcohols. Where did we do aldehydes? This one. So carbonyl compounds, they underwent nucleophilic addition reactions. Like this carbonyl group is highly polar. The carbon is positive, the oxygen is partial negative, and the Cn-1 gets attracted to it, and the Cn-1 comes and joins with the carbon atom. And the double bonded electrons, the pi electron cloud gets repelled, ends up forming O-1 at the top, which then attracts an H positive from another HCN molecule and ends up forming an alcohol at the top. So that is what's going to happen. And I'm going to write down the whole reaction for this because he's talking about ethanol. Now, ethanol is CH3, C, double bond O, and H. The carbon here is positive, the oxygen over here is negative, the Cn-1 comes in, the electrons over here, they get repelled. The intermediate that is formed is CH3, Cn joins in, and the O at the top forms a negative ion. So what's happening in this reaction? He's saying what changes in bonding are occurring. And in the last step, there's an HCN molecule coming in. The positive H is going to get attracted to the negative electrons. Now, a carbon-carbon bond is formed, which is true. A carbon goes and attaches to another carbon atom. So the first statement is correct. Then it says a carbon-hydrogen bond is broken, which is true because it is being broken over here. Like HCN is being broken. I mean, the H gets attracted to the O-1 and it bonds with it. So a carbon-hydrogen bond is being broken in the reaction. And the final step is carbon-nitrogen bond is formed. That's not formed anywhere because the CN bond always, I mean, the CNs, they always remain together, even in this other, I mean, nothing is happening, no change is happening to the carbon-nitrogen bond. So the third statement is not correct. ठीक है, is this clear? Bhaskar, is this clear? Taha,
Yes, sir.
Ethan, Mohammed, is this clear?
Yeah. Yes, sir.
Okay, this one. Now this one is a difficult one. Which pair of reactions could have the same common intermediate? So you have to think of what this intermediate could be. Now, there's a CN coming in. ठीक है? How do you attach a CN to a molecule? Now there's one way, which is this one. But over here, you don't just attach a CN, there's an OH getting attached as well. So you don't want the OH. So it's definitely not the above reaction. There's another halogenoalkane reaction. Okay, this is halogenoalkanes, where a CN, I mean, where is it? This one. So if you have a halogenoalkane, okay, let me highlight this. Okay, so if you have a halogenoalkane, the halogenoalkane Cl is going to get substituted by OH, CN, and NH3. Now we only wanted a CN, which is why I'm not going to go with nucleophilic addition. I'm not going to choose that path. I'm going to select this path, that a CN would simply come in and get attached to the carbon chain. That's it. But for that, I need a halogenoalkane first. So that indicates that the intermediate over here must be a halogenoalkane. And on which carbon would the Cl be? I mean, if you look at this molecule over here, there's a CH, CN. So there's CH, CN. I mean, this right side is CH and CN. And there are two CH3s attached to the same carbon atom. Now that means that the Cl, because I want the CN on the middle carbon atom, which means in the intermediate stage, the Cl would definitely be on the middle carbon atom. That is why the CN is also getting attached. I mean, if you look at this molecule, that is the reason why the CN is also getting attached on the middle carbon atom. So to get a CN, I need a halogenoalkane. So that should be my intermediate. Okay. Hiba, Rida, is this clear? Aiza, is this clear?
Yes, sir.
Sir, can you repeat this?
Okay, I'm going to repeat this. I'm starting at this point. Okay, I want a CN in the chain, and I want the CN on the central carbon atom, right? So how many reactions are there which introduce a CN into the carbon chain? There's one that we studied over here, nucleophilic addition. Okay, but it wouldn't be this reaction because in this reaction you get a alcohol as well. I mean, there is no OH group forming. Bhaskar, is this clear?
Yes, sir.
So the only reaction I have left is, I mean, there's just two reactions that you studied which introduce a CN in the chain. So the reaction would be for a halogenoalkane getting converted into a CN. The Cl gets substituted by CN. This is nucleophilic substitution of halogenoalkanes. Okay, this was the reaction sequence that the Cl carbon is partial positive. So the nucleophile, whatever the nucleophile is, OH -1, CN -1.
Acha, yes, okay. I get it. I get it.
So the only point was that the Cl must be on the central carbon atom. That's the thing that you have to figure out. Acha, what about this one? Now look at this reaction. Now there's a CN and an OH. Acha, the problem is that the OH is already there. So which again means it's not going to be this reaction. I mean, it's not going to be a nucleophilic addition reaction. And again, the CN is on the central carbon atom. If you look carefully, I mean, focus on this carbon atom in the middle. So this carbon atom in the middle is bonded to two CH3s. And there's a OH group. And then there's a CN group as well. So it's again three carbon atoms. So it's again three carbon atoms. The OH is on the middle carbon atom, which means before the CN came in, there must have been a Cl over here. So look at the first intermediate and look at the second reaction intermediate. They're both different because this intermediate already has an OH group. So this it already has an OH group, so that's definitely not the reaction. Now this one, look at Y. We have an alkene, and we want to convert that into an alcohol. Now there are two ways of doing that. You can either directly do that, like a double bond, a water molecule can get added over here, and it would. Okay, so I'm looking at Y now. So it's CH3 and there's a C double bond C. What I can do is I can just add a water molecule with phosphoric acid catalyst and 60 atmosphere pressure. That would be an addition reaction. OH and H would get added and the double bond would go away. That is known as hydration. But the problem with hydration is that it's a one-step reaction. We don't want a one-step reaction. We want something to be formed in the middle over here. And the same thing happens. If you look at halogenoalkanes, you would notice that in a halogenoalkane, the Cl might get substituted by OH as well to form an alcohol. So what I can do is I want two steps in the reaction instead of just one step. I mean, I can get the same thing with hydration, but I don't want one step. I want two steps because the question says that there are two steps happening. So what we can do is instead we can choose this path that there's a double bond. I can add HCl to it. Like H could be added and a Cl could be added. That's an addition reaction. And then nucleophilic substitution could happen and the Cl can be replaced by OH. And you can get this molecule over here. To get this one over here. Uh, so the intermediate would be this one. Mohammed Ethan, is this point clear? Aiza?
Yep.
Bhaskar?
Yes,
Yes,
sir.
sir.
Yes, sir.
Abba, is this clear? So I'm just going to repeat, which is that I'm just going to repeat that we could have gone from alkene to alcohol in one step. But since he was looking for an intermediate, we actually took a detour. We converted it into a halogenoalkane first, and then we substituted the Cl with an OH. Now, look at the first one and this one. Both intermediates are exactly the same. In the first one, the Cl was attached on the central carbon atom. I hadn't drawn the complete structure, but the Cl was attached on the middle carbon atom. And the same is true over here. The Cl is attached on the middle carbon atom, which means that W and Y are going to have the same intermediate. I mean, they can possibly have the same intermediate. So W and Y is the answer. Uh, if you choose path Z, if you look at path Z, this path has an ester. So the only possible intermediate is that you would break the ester. I mean, that's how you can get reduce the number of carbon atoms because you want 3 carbon atoms. The product has 3 carbon atoms. So you'll get rid of the ester. When you get rid of the ester, there is going to be an alcohol produced over here, an alcohol and a carboxylic acid. So you're never going to get a halogenoalkane or a Cl in the middle carbon atom. So the intermediate would be totally different. So is this question clear, Rida? Hiba, is this clear?
Can I ask a question?
Yes.
For reaction Y, could we add any acid, or do we have to put HCl?
But you can possibly add. So you can possibly add HCl, HBr. You can add HBr because the question, I mean, they had used this code was in italic. The intermediate could be many things. I mean, there could be possibly many different reactions. But what they wanted was Okay, which two paths have the possibility that they have the same common intermediate? Do you get my point?
Yes.
So you could have used bromine. I mean, this could have the OH might get substituted by, I mean, this path over here. You could have added HBr. So the Br would be on the central carbon atom over here. And later, what you could do is the Br could be replaced by OH. And in the first one as well, you can do free radical substitution with Br. And the Br could come on the central carbon atom, and the Br could be knocked out and replaced by Cn. So remember this, you just have 1 minute to do this. Now what you're going to do is when you're attempting, you just have 1 minute and 20 or 30 seconds to solve this question. Whenever you see this question, don't do it. Okay, just skip it. Okay, think you have to strategize because time is going to be an issue in MCQs. If you have time, try and solve this question because think strategically what you're going to because this question can never be. I mean, it's going to take at least 5-6 minutes to solve this question. So the point is, when you're attempting the paper, try and aim to solve 36 questions in the allotted time. Assume that you're going to miss out on 4 questions. Now, if you try and attempt this question early on, you're going to waste a lot of your time, and very little time would be left for the other MCQs. So, whenever you get big questions where you think that involve a lot of working, leave those questions till the end because if you try to attempt, it's 1 mark question. This is a 1 mark question. Every question is a 1 mark question. So if there's a question like a simple question, for example, like this one, I mean, you can solve this in 1 minute if you know what the mechanism is, right? It's a much easier question. Uh, this one is going to take a very long time. So whenever you see questions that you think are going to be very hard and they're going to take a very long time, remember it's just a 1 mark question. Okay, jump to the other questions if you have time at the end. Then go for. I mean, obviously you're going to attempt this question at the end as well, uh, or you're going to target to attempt this question at the end, but leave these questions till the end. You can think of 4 questions that you're going to miss skip in the beginning, which you think would take up a lot of your time. Keep those questions till the end. So this one. When santonin is first treated with warm dilute H2SO4 and then the product of the reaction is treated with cold acidified KMNO4, a final product X is obtained. How many atoms of hydrogen in each molecule of product X can be displaced with sodium metal? Starting with the first thing, what does H2SO4, dilute H2SO4 and heating with it, what would it do? You're going to notice that it has a ketone. I mean, there's a ketone. Then there's a alkene. I mean, the alkene groups. And what is this? This is an ester. Okay, this is C double bond O and O in the middle of the chain. So what happens when you heat it with dilute acid? The ester link is going to break and it would form, I mean, the double bond O side would change into a carboxylic acid group and the single O side would change into an alcohol group. So that is exactly what's going to happen. I'm going to break the molecule over here. The ester will get hydrolyzed. And this side would change into C double bond O and OH. And this side would change into an alcohol. Okay, so the middle part has broken. Is this clear? Ethan, Bazga,
Yes,
Taha,
sir.
is this clear?
Yes.
So, yeah, but it's probably, and there's nothing else. I mean, the ketone, no effect on ketone. We have studied no reaction where ketones have anything to do with H2SO4. And then he's saying that the product of the reaction is treated with cold acidified KMNO4. Now, cold KMNO4 was used to oxidize uh, alkenes. Okay, if you can have a look, probably this one. Okay, we did oxidation of alkenes. So far we've done actually very few questions on alkenes. I mean, very few questions have come on alkenes. Everything is kind of revolving around alcohols and aldehydes and ketones. So this part over here, this is strong oxidation, this is mild oxidation. So what we have done was that whenever you have cold dilute alkaline KMnO4, what happens is that the double bond breaks, not completely, changes into a single bond, and OH groups get added. Diols are produced. The same is happening over here. Whenever you see a double bond, the OH groups they get added to those double bonds. The same we're going to do over here. So you have these double bonds. So I'm going to change those double bonds into single bonds, and OH groups will get added to these carbon atoms. So mild oxidation takes place. Now the question is, he's now reacting product X. I mean, this is X now. Okay, this is the final product. Now he's reacting this thing with the sodium, with Na. Now, if he's reacting it with Na, we know that two things react with Na. One of them is carboxylic acid, the other one is alcohol. So alcohols, the only acid reaction that they undergo is the one with group 1 metals. So in each case, what happens? If you have an alcohol, the Na is going to come in and it's going to form a salt. If you have a carboxylic acid, the same thing would happen. The metal would come in and would knock out the H and take its place, and they would end up forming a salt. So how many alcohols or carboxylic acids do you have over here? There's one. So that's one H getting displaced. Two, three, nothing happens to ketone, that's four. This is an alcohol, five, and this is the carboxylic acid OH, that's six. So how many H atoms, how many atoms of hydrogen? That's six. D is going to be the answer to this question. ठीक है रिदा हेबा Abba, is this clear? Bhaskar, is this clear? Ethan, Mohammed, is this clear?
Yes, sir.
Yes, sir.
Yes.
Okay. Just one second, let me write a message. Okay, now next one. Okay, remember MCQs. If you practice MCQs a lot, okay, initially don't practice theory questions because theory questions are a little more straightforward. MCQs are kind of a lot tougher. So, I mean, your concepts, your knowledge of organic, etc., it gets revised a lot when you do uh, do these MCQs. Now, this one, which compound is optically active and can also be oxidized to a ketone? What changes into a ketone? That's secondary alcohols change into ketones, right? They get oxidized to ketones. So you're looking for a secondary alcohol. So which compound is optic? Now you have to, now the problem is you would have to draw all of them. One shortcut is don't draw the hydrogen atoms. It's just a waste of time. So it's butane one all, right? So that's four carbon atoms, and one all means there's going to be an OH here, and two methyl means there's a this is going to be the second carbon atom. There's going to be a methyl on this second carbon atom. So is this a secondary alcohol or not?
No.
ठीक है, it's not क्योंकि there's two hydrogen attached to the alpha carbon atom. So that's not a secondary alcohol. What about the second one? It's going to be hexane 3 also. That's 1, 2, 3, 4, 5, and 6. And it's 3 all, which means the OH on the third one. And there's 3 methyl as well. So what type of alcohol is this?
Tertiary.
ठीक है, that's a tertiary alcohol because the carbon alpha carbon is bonded to 3 carbon chains. So that's not even going to get oxidized. What about 3-methyl pentane 2-all? Pent is 5 carbon atoms, so that's 1, 2, 3, 4, and 5, and it's 2-all, which means there's OH, and there's 3-methyl. So meth is 1 carbon atom. Is this a secondary alcohol?
Yes.
Okay, it is a secondary alcohol because the carbon is bonded to two carbon chains. On one side, there's going to be an H. So it's a secondary alcohol. I mean, it fulfills that condition. And is it going to be optically active as well?
Yes.
Yes.
Okay, I mean, the same carbon atom is actually optically active as well because on all four sides, the groups are different. I mean, over here on this side, there's a huge carbon chain. On this side, there's one carbon, H on top and OH on the at the bottom. Okay, so this one is option C is going to be the correct option. Next one is what is the skeletal formula of 2-methyl pentan 1-ol? So pentan 1-ol. Pent, that's 5. 1, 2, 3, 4, and 5. 1-ol means the OH is on the first one, and 2-methyl means one carbon here. So draw the skeletal formula. That's 5 carbon atoms in a row. So that's 1, 2, 3, 4, and 5. Is it 5? You have drawn 6. This would be OH. So that's 1, 2, 3, 4, and 5. And on the second one, there's another carbon atom. So that's another one. So which one is it? I think it's the
C.
T gets C. So C is the correct answer. Then this one is the hydrolysis of a tertiary halogenoalkane. Look at the carbon atom. It's bonded to 3 carbon chains. It's a halogenoalkane. So just a quick recap. The quick recap was this was SN1 mechanism. That if your carbon is bonded on all 3 sides by carbon chains, then the nucleophile is going to come in the second step. It's not going to attack initially. And the reason it's not going to attack initially is that the carbon over here is not very strongly partial positive. Why is it not very strongly partial positive? Because if the Cl pulls electrons, the carbon over here has lots of big carbon chains around it. It has lots of electrons around it. So the positive charge is not very strong. Even if Cl is very highly electronegative, the positive charge over here is going to get distributed because it's going to pull electrons from all sides. So which is why the carbon is not interested in the nucleophile initially. So in the first step, you would wait for the Cl to break off on its own. And when it breaks off, a very stable carbocation is formed because the positive charge is not very strong and it's not going to attract the Cl minus 1 back again. Why is the positive charge not very strong? Because large groups are attached to it. They have an electron donating effect. Big carbon chains are attached. So they're going to contribute their electrons and the positive charge density would be lesser. So the positive charge over here is going to be very less, which is why it would allow the Cl minus 1 to break off easily. It's not going to attract this. And if the OH ion concentration is sufficiently high enough, then there would be a very bright chance that the OH minus 1 would come and attach with the carbon atom over here and an alcohol would be produced. So it was a two-step reaction where the first step was a slow step and the second step was the fast step. And this was known as the SN1 mechanism. Remember, for tertiary halogenoalkanes, it's always the Cl breaking off first and then the nucleophile getting attached. For a primary halogenoalkane, the positive charge on the carbon is very strong. Why? Because there is no electron contribution from the sides. The H has no electrons to begin with. I mean, H only had one electron, so its neighborhood doesn't have a lot of electrons. So the positive charge is very strong, and it attracts the nucleophile right from the first step, and which is why the OH would start bonding with it, and then slowly the Cl would break off. So, anyways, this was a two-step reaction. This was the tertiary halogenoalkane, and it was a two-step reaction, which is why hopefully if you can see properly, this is going to be C. Like it's going to be first step followed by the second step. The second step is always going to have a smaller peak. The, the second step is always going to have a smaller peak, and the reason for that is that when you reach the intermediate point over here, you want the reaction to go forward. So the activation energy for the forward reaction should be lesser, uh, which is why it's going to be C. Both C and B, if I draw B properly, it actually looks like this. So the second peak should not be higher than the first peak, because once you reach the intermediate stage, as you can see in the reaction as well, like once we reach the intermediate stage, the second step was actually the fast step. Fast step means that the activation energy for the fast step is always lower. The reason it is the fast step is because it has a lower activation energy. So the second peak has to be lesser. It has to be faster. The first one is slow. That means the first one has the higher activation energy. Is this point clear? Abba, is this clear? Ethan, is this clear? Rida, Hiba?
Yep.
So hence, it's going to be this one. That's the next one. There's this polymer that's being formed, and he's saying what is the monomer. So how do you figure out the monomer of a polymer? Uh, if you look carefully, this is the repeat unit. They're all identical. But what you would notice is that each one has a Cl. It's just that one is, I mean, they're not arranged in an orderly fashion, but they're exactly the same molecule. Each one of them is going to be, it's going to be an ethene molecule with one Cl. That is what the monomer is going to be, which means it's going to be CH2 and CHCl. So it's going to be B. Each one is the same. It's just that one is upside down, one is laterally inverted or horizontally flipped around, but they're exactly the same. Okay? I mean, the CL might be pointing upwards, the CL might be pointing downwards, so they would be flipped around versions, but they're exactly the same. Hence, it's P. Is this clear? Baza, is this clear? Taha?
Yeah.
That's the next one. You have this molecule over here. He's saying which starting materials would be required to synthesize 2-methyl 2-methyl butyl ethanoate. This molecule over here. So it is an ester. If you look carefully, just break the ester. The starting materials would be. I'm not going to draw the hydrogens. I mean, this side would be the carboxylic acid side. The other side is 4 carbon atoms, and there's a carbon atom over here, and there's an O. This O would change into an alcohol. So those are your starting materials. Now, it's either going to be this option or it's going to be this option. So the only problem is now which one. I mean, he's drawing the condensed version of this. So if you, I mean, in both cases, I mean, this is obviously incorrect because it's a carboxylic acid. I mean, you want a carboxylic acid, the other side should be an alcohol. So you don't even have to look. I mean, this would be the right option. I mean, figure out one side would be ethanoic acid. That's given over here, ethanoic acid, ethanoic acid. The other side would be an alcohol. So I don't even have to draw the structure because the only option over here, there's only one option for an alcohol, so it's going to be B. But they've drawn the condensed version, so it's going to be CH3, CH2. I mean, if I draw the condensed version of this, and if I try to go from right to left, the first one is C with 3 H's, the second one is C with 2 H's. Uh, then I have CH, and the CH has a CH3 branch, so that would be put in brackets. Then there's going to be CH2, and then there's going to be OH. So it's the same molecule written the other way around. So that's the answer to this one. Is this clear? Isaiah, is this clear? Mohammed?
Yes, sir.
Yes, sir.
Yes.
Let's now this one. Complete combustion of compound X produces carbon dioxide and water, and only X produces steamy fumes with PCl5. So it is reacting with PCl5. And what reacts with PCl5? Alcohols react with PCl5. Where are alcohols? I mean, alcohols was somewhere, not this one. Just one second. So alcohols, they react with PCl5 to form halogenoalkanes. I mean, this is formation. Anyway, I think we did that in halogenoalkanes in this one. So PCl5, very vigorous reaction happens. Um, the OH gets replaced by Cl. So that is what's happening. So alcohols react with PCl5. So I'm going to go back, and I know that this is an alcohol because it's vigorously reacting with PCl5. It's forming steamy fumes. Now it says X does not give any visible product with 2,4-DNPH, which means that 2,4-DNPH was a test for carbonyl group for aldehydes and ketones. So what can be deduced with certainty from this information? Um, Now we're saying what could be deduced with a certainty. Um, the first one is it is not a hydrocarbon. That's definitely not correct. It's not a hydrocarbon. Uh, I said now it's an old question. The problem, the option that can be deduced with certainty is that it's not an aldehyde. I mean that's 100% correct. I mean if it's not giving a test with 2,4-DNPH, it's not an aldehyde and it's not a ketone. That is the only thing that's certain, 100% true. So he was saying what could be deduced with complete certainty. Actually, the problem is that there was one reaction that happened with carboxylic acids and PCl5, which has been removed to A levels now in A2. So with PCl5, carboxylic acids also react and alcohols also react. But now they've actually removed the carboxylic acid reactions, taken that to A2, which is why uh, if we had that reaction as well, then there would have been confusion in this. So it's an old question, which is why. Do you get Taha? I'm just explaining. See that carboxylic acids also react with PCl5, except that that reaction is no longer in AS. So both of them they actually react with PCl5. So you can't be certain okay, it's an alcohol. It could also be a carboxylic acid. But this option A is now actually removed. I mean, this reaction is no longer in your course. Taha, is this clear?
Sir,
Ethan
for
is
the
Mohammed is this?
question,
Yep. Yep.
when it says X produces carbon dioxide and water, uh, does that mean it has a it has a double bond as well?
If it produces carbon dioxide and water, that means that what does that mean? It means that there would be no Cl atom in it. Okay, just a second, my board is not writing. Okay, so that means that it's either a hydrocarbon that it contains carbon and hydrogen atoms, right? But it could also be a carbon and hydrogen atom, and it could also contain oxygen atoms because only carbon dioxide and water is getting produced. So you can't say for certainty that it's a hydrocarbon. Hydrocarbons do produce carbon dioxide and water, but hydrocarbons which have like carbon and hydrogen and oxygen, they also produce the same carbon dioxide and water. Ethan, is this clear?
Yep.
Sir, PCl5 with carboxylic acid also produces steamy fumes?
Huh. But that reaction is no longer in your course. So which is why there would have been confusion between A and C. Like you can't be certain that it's an alcohol because it could be a carboxylic acid. But now they've taken that the first reaction into A2. So you would probably not get options like this anymore.
Okay.
ठीक है, clear?
Yes.
So let's just do one more question that he's saying that organic compound X is unaffected by hot acidified potassium manganate 7. So anything that gets oxidized, this is not it, which means that it's not an alkene, it's not an alcohol, it's not. I mean, it could be a tertiary alcohol. Anything that is resistant to oxidation. Anyways, the board is not writing, so I'm just going to explain it here. So it can't be a primary alcohol, it can't be a secondary alcohol, it can't be an aldehyde, it can't be an alkene. So I mean, this is a possibility. This is a tertiary alcohol. If you draw this molecule, this one is a tertiary alcohol. The carbon has 3 CH3s attached to it, so that's a tertiary alcohol. It's not going to get oxidized. Then this is a secondary alcohol. It's CH and OH. If you draw this molecule, this is a secondary alcohol. This cannot be the correct option because secondary alcohols, they do get oxidized. This one is a ketone. I mean, there's a CO, so that's a ketone. And the first one is an ester. Esters also don't get oxidized. There's no oxidation reaction. So it could be A, B, and C. And then it reacts with ethanoic acid in the presence of, so he's making an ester. Ethanoic acid, carboxylic acids, they make esters in the presence of sulfuric acid. So the only option left is going to be an alcohol. Carboxylic acids react with alcohols. Plus, it's a tertiary alcohol, so tertiary alcohols don't get oxidized. So is this clear?
Yes.
Yes.
Yes, sir.
So let's continue with this next class. My laptop is already, it's not responding.
Worksheet
So
on
we'll.
our WhatsApp. Can you send this worksheet on our WhatsApp group? Paper 1.
TK, I'm going to send both of these worksheets. TK, A2 and AS both. I mean the paper 2 and paper 1 both.
You have already sent paper 1.
So I'll send this one as well. Okay then. Take care, Allah Hafiz.
Thank you, sir.
Thank you.
Thank you.